Good evening, everyone. Welcome to today's webinar on AI security. Today's topic we'll be looking at understanding threats, building resilience, and ensuring data integrity as it aligns with AI security. My name is Aniel H. Jafaro, and I'll be taking us through this webinar uh, through to the end. Okay, so this is this is our first webinar as it aligns with AI security. Our previous webinars has always been focused on cybersecurity, but we're trying to see how we can bridge the gap because we know the effect AI would have on different industry, and that also includes the cybersecurity industry or sub-industry as it aligns with IT generally. So we're trying to see how we can look at job roles that will be necessary and needed in future, and begin to develop curriculums and content that aligns with those job roles so as to ensure that we are able to make many of us relevant while coexisting with AI and robotics. So today's webinar is focused largely on AI security. We have subsequent webinars that will be coming forth, but today's one is focused on AI security. So, like I said earlier, the topic is focused on understanding AI threats, building resilience in AI, and also ensuring data integrity in AI systems. So, what are the topics or the models we'll be looking at today? This webinar is going to be for 2 hours. So, the models we'll be looking at today include understanding the AI threat landscape, building secured AI model, and ensuring data integrity. Then the last would be AI system monitoring and proactive security measures. It's quite important that we understand these topics, and these topics tends to be a minute size compared to the extensive covering or topics that one needs to understand as long as AI security is concerned. So AI security is more of like a branch of cybersecurity, but it's more focused on AI because of the fact that as a result of AI, we're going to get more persons connected to the internet. We're going to see more things connected to the internet. So people and things would be connected to the internet, and we're also going to see robotics get AI gets embedded into robotics, and as a result of all this is going to change the way we operate, the way we process things, the way we analyze things. So AI is coming with a new is coming with a new form of solution, but also has its own challenge. Just like every coin has two sides, there is always the head and the tail. So AI comes with that same challenge, both as a solution and a challenge. So we'll be looking at these four topics again. At the end of it, we'll have the liberty to ask questions if we want to ask questions. But the questions that we'll be asking would be largely on our various. Uh, we'll have to ask our questions via the various channels that you submitted uh, your registration. Those that are connected are largely those that have received an email detailing their registration and the webinar details. So let's start. So introduction, what's AI security? So AI systems generally have their own unique challenges and they have their own unique vulnerabilities. The challenge with AI system is the fact that unlike cybersecurity, which is largely focused on infrastructure and the application that runs on infrastructure, AI goes beyond that. AI security focuses goes beyond just the infrastructure. In fact, AI has five different components. There is the AI model, which is there is the AI model, there is the AI algorithm, there is the data training set, there is the AI infrastructure, and there is the AI application. So each of these components tends to have its leverage or tends to have a security concern. Cybersecurity largely focuses on application and infrastructure. But now we are seeing that, okay, cybersecurity focuses on infrastructure, application, and data. But now we're seeing the introduction of two additional model or two additional component, which is the model and the algorithm. So we need to understand that these are existing threats, and this is what AI security largely focuses on. Now, AI security is a combination of three key components. It's a combination of cybersecurity, which is the security of most of all these components. It also combines data privacy, which is ensuring that one is able the data that is being used to train specific AI it has privacy attributes embedded into it, or privacy concerns addressed in those data, and also integrity. Integrity is the bedrock of any AI system, because once an AI system loses integrity, it loses the trust that is needed it loses the trust that is needed, and stakeholders, which includes the users, would find it difficult to trust the AI system, which would mean that they won't be able to use, not that they won't be able to use, but they won't have they won't be able to engage with that AI system as they would have done without any misintegrity or disintegrity. So there is a huge concern on adversarial attack. Adversarial attack largely is attacks that tends to focus on the input to give to an AI and what it brings. Like if you tell AI, if you ask ChatGPT, for example, generate me a text, ChatGPT would give you an output. The input is generate me a text, which is the prompting. The output is what it brings out to as a result of the input that you give to it. But however, there is a way you can actually send an input for it to generate a wrong output. So that form of attack is known as adversarial attack. And this form of attack is largely growing on a continuous basis and a consistent basis because of its dynamic nature. It's quite difficult to mitigate this form of attack. So are constantly being engaged. Researchers are constantly engaging innovative way of providing defense mechanisms that will help in mitigating this form of attack. So why is AI security important? The first reason why AI security is important is the fact that AI is largely going to be integrated into various aspects of our lives. Our healthcare, our patient data, our financial transactions, and the likes are largely going to be embedded with AI. And because all these things would be embedded with AI, it now means that it's important that we secure the AI system. Because if AI systems are not secured, it now means that our data that has been used to train the AI system, or that is our data that is currently being used within these sectors, be it the health sector, the finance sector, and other sectors, tends to would cause identity theft and other security challenges to an individual, to a company, and also to a nation. So it's crucial that AI systems have trust embedded into them, and the AI system is reliable. Because how do you address issues where there is the system, the system does not have is not reliable as it should be. For example, if an AI system, an AI navigation model is supposed to direct you to a particular place, what about a situation whereby the model is not reliable, and in the course of directing you, it either crashed or something happened to the model and it's unable to direct you to where you are. And probably it started well, but in the middle of nowhere, it just went off or went blank because it doesn't know what else to do. So situations like that can be dangerous and challenging. So that's one of the reasons why we have to ensure that. That's one of the reasons why AI security is important. So let's start with understanding AI threat landscape. So AI threat overview. As AI system generally are prone to a wide range of security threats. Like I said, there are five major components: the the model, the algorithm, the data, the application, and the infrastructure. Those are the five major components that forms an AI system. Now, each of these components is a landscape and a surface to an attack. So an attack can happen to the AI model, an attack can happen to the AI uh, the algorithm, an attack can happen to the data, an attack can happen to the infrastructure, an attack can happen to the application. So the landscape and the surface for AI systems is largely broad. And because it is broad, And because it is broad, it now means more work needs to be done in the area of defense, in the area of mitigating these attacks. So the general overview is the fact that AI surface uh, is broad and the landscape is broad. And because the landscape is broad, you have more potency for attackers and criminals to be able to launch an attack on these various components. And it's quite important that we are able to address the security concerns in each of these components. So by addressing the security concern, we are mitigating the risks that comes with it. But now let's look at even the major risks and vulnerabilities attached to AI system. One of the major risks and vulnerability that is attached to an AI system is adversarial attack. Adversarial attack is an attack whereby somebody or an attacker or a malicious actor craft an input that tends to mislead the AI model from giving a wrong output. There are different ways this happens, and there are different types of adversarial attack. In fact, one of it clearly it was in one of our Udemy courses. Uh, um, Mastering AI security. This is one of this adversarial attack was largely treated and dealt with in that particular course. So we need to adversarial attacks. There are different types of adversarial attacks. There is adversarial attack that is largely focused on ensuring that the expected output is generated based on the inputs that you have given the AI. So let's say, for example, you ask an AI, write me some write me I you ask an AI system to generate list of colors, and you have crafted the input in such a way that you want the AI to generate seven, but in the input, unknown to the human eyes, that you have already subtly, unseen by humans, or unseen by the human sense organ being the eyes, that you have asked the AI to actually list five, and you have actually given the AI five of those colors that it will list. Based on that input, even though those five colors, those additional requests you made, we are not seeing it, but it has been made. It was there. Let's say you let me okay now. Let's say you type the question, and the question is, give me recommend five colors. Then underneath the question, you type another question. Make sure the colors are red, orange, blue, purple, and green. Now, the red, orange, blue, purple, and green can be in such a way that nobody sees it. So if somebody opens that document, they will only see the question you are asking. They will not see the response you are giving the AI to respond. So once you upload that particular question to an AI system, the possibility that the AI system is going to give the response back the possibility that yes, they're going to give the response back based on the input that you give. Another example is in the case of a job CV. You are asking an AI system is trying to filter job. An AI system is trying to filter those that qualify for a particular job that will qualify for a particular job interview. So in your in the CV of the malicious actor now in his CV, he will put in all the necessary information that he has, but let's say at the last page of the CV, he can decide to put in additional qualification that he does not have, but the AI system will consider that qualification to be something that he has. Why? Because when if an HR professional opens that CV, the HR professional will only see all that is written in black ink, and we're not seeing the remaining that are written in white ink because the background is white. So the HR professional will not see those other additional thing that he has added. And now, once that particular file is uploaded into an AI model to decide whether it qualifies for a CV, let's say, for example, the person you want somebody that has a PhD, and the person does not have a PhD. But underneath his CV, he highlighted that he has a PhD and made that particular portion of the CV to be white. Now, the portion of the CV is white, the background of the CV is white. When somebody opens that CV, the person would not see that portion that is white. And because the person is not seeing that portion that is white, the person will just upload the CV into an AI model to decide whether this person is qualified for the interview or not. Now, the AI system cannot determine whether the color, it will only determine the words. And the words on the CV include both the words that are written in white color and black color. So the AI system will consider that CV to be qualified because as long as the AI model is concerned, that particular CV meets the requirement and there is a PhD portion attached to that CV, even though the HR will not see the PhD portion. So that's adversarial attack. So the adversarial attack is a way of crafting input that deceives or misleads the AI system to give a wrong output. Then there is data poisoning. Now, data poisoning, for an AI system, for an AI model to exist, it needs to be trained, and it is trained based on data. Now, the process of training is called the process whereby an algorithm is modeled or trained is called AI modeling. So modeling is the process of whereby an AI system or an algorithm learns the pattern in a data. So if, for example, you give the data you're sending to an AI are different colors, and you are telling the AI to be able to identify or classify each of those colors. So you send it a color, it tells you this is red. You send it another color, it tells you this is green. So the challenge now is that because the AI system is able to classify the colors specifically, the AI system can largely tell you what is what based on the data that was used to train it. How about a situation where the data that was used to train the AI system is poisoned? For example, now, if we're looking at a training method which is known as supervised learning, whereby you give the AI system different shades of green, and you tell the AI system that this particular color is green, and you give the AI different shade of purple, and you tell it that this particular color is purple. How about a situation whereby you give the AI system green and you tell it that the name of that color is purple, or you give the system purple and you tell it that the name of that color is green? The AI system would learn purple as green and learn green as purple because of data poisoning. That's a form of data poisoning whereby the AI system learns wrongly because of the data that was used to train it. So that is also another risk. We have the risk of the model, the data you're using to train an AI to be. We have the risk of having the data you're using to train an AI to be poisoned, and this is a huge risk. Then there is model inversion. Model inversion is a way of re-engineering the model, reverse engineering the model in such a way that sensitive data that was used to train the model is exposed. So a particular data, you have used the data of somebody that is in a hospital, or a patient data to train an AI. How there is a way that there is a risk of revealing that particular data and that particular data, beyond just revealing the data or exposing that data, the patient data would be able to the malicious attacker or malicious actor will be able to identify whose patient data it is. So there is a risk of model inversion, which is a way of reverse engineering the model to be able to expose sensitive data. Then the fourth, there are a whole lot of risks actually that comes with it. There's operational risks, there are technical risks and the likes. But as we are looking at the technical risks at this point, so the fourth risk and vulnerability that comes with AI system is membership inference. Membership inference is a way of sending an input to an AI system and making the AI system to okay. Membership inference is a way of detecting if a particular data has been used to train an AI model. So you want to know if Amaka or Johnson's data that is resident in a particular hospital in the UK, if his data was part of what was used to train a particular AI model. So membership inference is a way of determining if that particular data was part of the data that was used to train a particular model. So these are some of the risks and vulnerabilities that comes with AI systems, and there are a whole lot. We largely focus on the technical risk, but there are operational risk, there are administrative risks that comes with AI systems. So we need to take note of some of that. Then there are different types of AI attacks. Which largely form some of the risks that we have seen. One major type of AI attack in this dispensation and in this time is adversarial attack, which I have explained earlier. So adversarial attack, which I have explained earlier, adversarial attack is largely the attacks that modifies an input. It modifies an input to deceive the AI system. So now, for those of us that are in cybersecurity, we probably would understand the concept of social engineering, which is a form that manipulates the human nature of trust. So you manipulate somebody to give you what he or she does not want to give you. So that's it. But in the case of AI system, when you're asking an AI system to give you what on the norms it's not supposed to or it shouldn't, that act is known as adversarial attack. So it can be a form of misclassification, misidentification, wrong classifications and the likes. So what you do is that you give it an input, you modify an input and you give to it, and you expect an output, and the output is what you actually intend. You want it to give you a wrong output, or you want to give you a wrong output that you know is wrong. So though that's the first form of attack to AI. Excuse me. The second form of attack and type of AI attack is data poisoning, which I've explained earlier. Data poisoning is when you insert malicious data into the training set. Like I said, there are 5 major components: the algorithm, the model, the data set, the application, and the infrastructure. So data poisoning is when you insert malicious data into the training set. That's what it means by poisoning. So you have various data set that you have prepared to use to train a particular AI model. If someone is able to insert additional data set that has not been approved into that particular data set that you want to use to train the AI model, and all those data sets together were used to train the AI model, it means that the data has been poisoned. So the AI has been trained with a poisoned data. So that's vulnerability. I mean that's a form of attack. Then there is the model evasion. Model evasion is a way of bypassing AI defense system by modifying attack patterns. So we have various security technologies that uses AI. So it uses AI to determine if an attack is coming to the regular information system assets, like our systems, our desktops, our laptops. So if uh, the AI system that was embedded into those security technology is unable to detect an AI, it means that the attacker has embedded what is known as launched an attack on that AI system, and that attack is known as model evasion. So it's evading being detected by a security or a malware detection technology. So let's say a malware infects a system. Now, an antivirus, for example, or a malware security is supposed to detect that malware that infects a system. But if a malware security is unable to detect that malware that infects a system, it means that that particular malware has embedded a technique known as model evasion, because it's evading uh, a model, or it's evading an AI model from detecting it, even though the AI model is expected or supposed to detect it based on the behavior on how the AI model has been trained. So building a secure AI model, building secure AI model. So let's look at the introduction to secure AI development. We have to ensure that AI models are robust and resistant to attack, because the truth of the matter is AI systems has to be robust, because you now train an AI system with all the data that you have. There are specific data that you use to train the AI system, and we were explaining robustness later on. But we need to understand that one thing we need to ensure when developing AI system is that the AI system should be robust. Then AI system must be integrated. Security, sorry, must be integrated into the life cycle of AI development life cycle. We don't embed security at the end of the development. We don't embed security at the application level. We don't embed security at the infrastructure level. You embed security from the algorithm, the data, and the model. Security a way. Security must be embedded into the design and development of AI system from the very beginning of the model life cycle. So the model life cycle starts largely with preparation and planning, and security must be embedded into it from that place to the design phase training, to data collection phase. All these phases must have security embedded into its processes and into its processes. And this would help to ensure that the AI system or AI model is secured. So we should not make the mistake that was made on the internet. The internet was not designed originally with security, because it wasn't expected to go global the way it eventually went. So because of that, there's no security embedded into it. So security became an add-on as against a core, instead of it being a core. So we should make AI security to be a core in we should embed security as core in AI development. So what are the key security techniques that we need to put in place when embedding AI security? One of it is adversarial training. Now, I made mention of the fact that adversarial attack is one of the major attack that AI systems experience. One of the major attacks that AI system experience is adversarial attack, and I said that's a way of manipulating the AI system to release sensitive information that it would not originally want to give, or to deceive the AI system from giving specific information that it shouldn't. So we need to understand that in order for us to mitigate adversarial attacks, we have to engage what is known as adversarial training. Adversarial training is when you train an AI to be able to recognize or resist adversarial input. So how would the AI know that there is a white ink content in that CV that I explained earlier? You need to now train the AI to know that, okay, any content that you're sending, or any file you are sending that is black ink, that's what you should use to determine whether a person is qualified for a particular position. So adversarial training there are different techniques to adversarial training. You can train it with examples. You can train it to be feature dependent, and different techniques in adversarial training. But generally, adversarial training helps the model to be able to recognize adversarial attack, and that is the key to mitigating adversarial attacks. So then there is defense distillation. Defense distillation is a security method whereby you use a train-the-trainer approach. So how does it work? How it works is that you train an AI model, then use the AI model, or you send AI data input to a model in the course of training. The model generates an output. So instead of the output becomes what would be used generally, the output becomes a teacher that you would now use to train. another model. So it's more of like distillation, trying to ensure that an AI system is less sensitive. And because if it is less sensitive, there is the tendency for it to be able to identify attacks, because it's a security method. So there's a possibility for it to be able to identify attacks. So defense distillation is an approach to simplify the model to reduce its sensitivity to adversarial changes. So then there is robust testing, which is also another security technique. Robust testing is ensuring that the AI system is able to withstand against adversarial scenarios. For example, an AI system needs to be designed to have robust, to be an AI system needs to be designed to be robust. And what that invariably means is that, let's say you are, for example, you are training an AI to be able to identify colors, and you have given it about data of 20 different colors. We have different colors, even though we know that there are the primary and secondary colors, but there are other colors, other shades of colors. What happens when the particular shade of color that was not used to train the AI is now what becomes the input? So what I mean is, you've trained an AI to determine black or white. You gave different colors, two sets of colors, white. Then two sets of color. One set it would be white, different shades of white. Another set will be another set will be black. So what happened? Robustness in AI model would mean now that, what if I bring a different color? Let's say I bring a red color. What happens? What will be the outputs that the AI will give me? So the AI should be able to withstand, should be able to recognize that that's a different color, even though that color was not part of the original color that was used to train the AI model. So it should be able to identify that particular color. And identifying that particular color makes the AI model to be robust. So it's robust to the extent that it's able to differentiate what was used to train it and what wasn't used to train it. And it's also able to going to predict the potential colors that exist, that you are sending it to it as input. So, how do you preserve privacy? Because privacy is a key concern in AI model, especially when you're trying to uh, train an AI model. So, I have the data of Johnson. I have the health data, patient data of Johnson in the UK. I have patient data of Alice in the US. I have patient data of Manam in Australia. And all these data, I want to use them to train a particular AI. How do I ensure that somebody would not just go to the system and bring in and put in an output, and all the patient records for that particular patient, or the Manam that is Australia, comes out with Manam's name, showing that this is Manam? You say, okay, a patient. Okay, now let's say I go to an AI system and I ask, okay, the patient has cold, and the temperature of the patient is this and that and this, and the patient is this and that. Okay, can you please tell me whose patient it is? Well, the AI system is not supposed to be able to give you that, because if it does give you that, it means that there is no privacy preservation embedded into the design of the AI system, because AI system needs to have privacy embedded. Privacy should be embedded from its design, just like security. So the AI system needs to be able to tell us that, okay, a patient has this particular record, but should not give us the name of the patient. That's embedding privacy. So we need to ensure that we embed privacy into the AI system, so that the AI system does not just release any information, that it release the information and identification of records that was used to train it. So how do we do that? One way we can do that is by embedding what is known as differential privacy. Differential privacy is a technique whereby you add noise to the data. So you have Alice data in the US, and from Alice patient data, we know that Alice went to the hospital on the 25th of March, went to the hospital on the 1st of August, went to the hospital on the 31st of January. Okay, so if you're trying to ask the AI system to give you the average time that Alice have been to the hospital, definitely the AI system will say, okay, an average of 3 times, or in a year, an average of uh, 0.3. So because of these, you are still pointing. There is a finger still pointing to Alice and making users know that that particular data is Alice. Why? Because there is no privacy embedded into it. So what happens now in differential privacy is you would now add a data to Alice data that does not exist. So you're saying you tell the system Alice also came to the hospital December 24th. Alice also came to the hospital January 15th. Adding That's what's known as noise. Adding noise to the data. So noise would be a data does not that is more of like a lie. Yeah. So adding noise is more of like adding a data that does not exist, but to a particular set of data, so that you are able to preserve the privacy of the owner of that particular data. Now, because you have added that noise, the data would now, if you are asking, okay, give me 5 persons, persons that has come to the hospital 3 times this year, it definitely will not bring in Alice, because uh, based on the noise that have been added, Alice came to the hospital 5 times. So that's generally that adding noise to data is a system, it's a technique called differential privacy. Then there is federated learning. Federated learning is a system whereby it's more of like a distributed learning methodology, whereby you take the data, you take the model. There are different, you use data sets to train models. So what you do is that you have like 10 to 20 different data sets. So, and the data sets, they are not centralized. They are Some persons do central learning method, which is where all the data would be in a particular space, and the data set will be used to train the model. But federated learning is you take the model to meet the data to the data at their different space or different location. So you can take the model to the data that is in US, use it to train it, come back, take the data to the UK, use it to train it, come back, take the data to Nigeria, use it to train it, come back, take the data to different space. So that system is known as federated learning. By doing that, you are helping to ensure that you are embedding privacy into the whole system. You are embedding privacy as a technique into the whole system, and helping to mitigate the risk of um, data breaches, because at this point you are not using one set of data that is centralized. You are using different set of data that are at different location. So ensuring data integrity. Ensuring data integrity. All right. So the introduction today is AI model largely relies on data. Data is what I consider it to be the most important aspect to building an AI system. If your data is wrong, your your AI model will be terrible. If your data is poison, your AI model will produce unreliable results, unreliable outcomes. So data is like the lifeline. That is the life to an AI system. And in fact, that's the reason why data become data was the major reason why we did not have an AI system, AI model before now. There was, apart from the computational issue that we didn't have, uh, we also did not have the data that is needed to use in training a particular AI model. But now we have the data. So data is a key component. So, but the challenge now is the integrity of the data, because how about you training an AI in Africa, in Nigeria, for example? Uh, okay, now let's take for example a country that is not recognized as a country that is recognized as a country. Hong Kong, for example, some countries recognize Hong Kong as a country. Some countries recognize Hong Kong as an independent state. So, what does AI recognizes Hong Kong as? Now, that question is a huge question that it would only be determined by the data used to train an AI. So if the data that is used to train an AI, the pattern in the data largely identify Hong Kong to be a country. If somebody asks that model what Hong Kong is, the output of the model will be that Hong Kong is a country. But if the data used to train the AI says Hong Kong is an independent state under the territory under the Republic of China, it means that they would not recognize it. So it's important that we the data that we're using to train the AI has integrity. The data has not been tempered, it has not been modified. And if modification has been done, it was done with authorization. Integrity is very, very important when discussing AI matters and AI development. So and because data is the most important aspect to AI development, because it is also the focus for attackers. So attackers want to engage and see how they can breach the data in the AI system. They want to see how they can expose the data used to train an AI system. So because of all of this, it's quite it becomes necessary and important that we pay so much attention to ensuring that the data that we use in training AI systems are secured and protected with the best protecting or security techniques. So some of the security techniques that can be used to train AI models include data encryption, includes data encryption. Data encryption largely that's encrypting. You need to encrypt data at rest and data in transit to ensure confidentiality. What this invariably means is that when there are data are in three states. We have the data that is at rest, we have data that is in transit, and we have data that is in use. So data that is in use are data that you are using. Like say you open a Word document, for example, on your system. That particular data is in use. You are trying to view a picture. That picture that you're trying to view on your phone, or that image you're trying to view on your phone, is a data that is in use. You're trying to do something, you're trying to browse, that browser is in use. So all the data you are using at that point in time, they are largely considered to be data in use. But how about data at rest? Data at rest are all the data you have stored on your system that you are not using. You've stored them, but you're not using them. You've stored them in your hard drive, you store them in your system, you store them in your flash, you store them on your phone. When you capture an image, and that image is stored and saved in your system, they are all data at rest. Then there is data in transit. Data in transit are those data that you are sending either via email. For example, you are uploading a file to a messaging platform like WhatsApp. Now, those messaging platforms like WhatsApp is largely considered to be data in transit, because as you are sending the data, it's moving through various nodes till it gets to its destination. So that's data in transit. So the challenge with this is that the data that is used to train an AI, the data that is used to train an AI is like the data is usually stored, but before it is stored, it is transferred. So the data in transit in this case can be you are transferring the data from a particular you are transferring the data from a particular vendor or data feed to your system so that you can train, especially when you're using the centralized training method, where that especially when you're not using the federated training method or learning method. So you would need to move the data from wherever the data is to that centralized place where you want to keep all the data. Now the data moving from there to your centralized system or storage facility is in transit. And because it's in transit, there is a possibility for that data to be intercepted and modified in whatsoever capacity and whatsoever way. So it's important that we ensure that while the data is in transit, it is also modified. While the data is in transit, it is also modified. I mean, while the data is in transit, it cannot be modified. And even though, and one way you can ensure that that happens is by embedding encryption. Encryption is a form, is a system of is a cryptographic system of converting plain text into ciphertext. So I am going to school in plain text can be in a language in ciphertext that you don't understand and nobody will understand it except with the decryption key that was used to decrypt it, or the encryption key that was used to encrypt it. So it's important that you understand that encryption can happen while data is in transit, so that even though somebody is able to capture the data, they won't understand the content of the data. And as a result of that, they won't be able to do anything because they don't understand the content. But if they understand the content, they can modify and send the modified version. So then there is data at rest. Data at rest are data that is stored on our hard drive. We need to encrypt the data that is at rest, the data on our systems, the data that is now on. When the transmitted data or the transferred data gets to that centralized system or storage facility, it is important that that encrypted data is that data that is in the centralized facility is encrypted. And the reason is because in case if there is a data breach, probably somebody picks up your data, steals your data, they will not understand the content of that data. Why? Because it is encrypted. It has been converted from plain text, which is an understandable language, to ciphertext, which is a language that is not which is to a form that cannot be understood, except when converted back to plain text. And I'll be explaining that in the next slide with the form of encryption and decryption. So encryption is one system and one technique you can use to prevent it, to ensure data has integrity. Another technique you can use to ensure that data has integrity is the concept of hashing. Hashing is also another way you can use to ensure that data has integrity. So how hashing works is that hashing is a one-way traffic whereby you use an algorithm called hashing algorithm to verify the integrity of a data. So what happens is that if you have a data, let's say I am going to school, I capital letter and the remaining small letter, when you hash that particular data, it generates a fixed, using depending on the hashing algorithm you're using, but it generates a fixed strange value. Now that fixed strange value can be the same thing anywhere in the world. If you go to US, you want to encrypt, you want to hash that same I am going to school with the same algorithm engine, is still going to give you that same fixed value. So let's say, for example, the fixed value is 1, 2, 3, 4, 5, 6, A. That's the fixed value. Anywhere you take it to, it's going to give you the same fixed value. But if you mistakenly change I, that is capital letter, to small letter, is going to give you a different fixed value, a different strange value that would be difficult for you to even be to know that it is just a capital letter that you change to a small letter. The value will be completely different from the previous one, even though the content you use to encrypt is the same thing. The only difference is that you change this capital letter to a small letter. Or if you decide to put full stop in one and full stop in the other, and you put full stop in one and you didn't put full stop in the other, the value, the hash value is going to be different, completely different. So you use hashing to be able to identify. So let's say, how do you apply hashing, for example? Before the data is transferred, you hash the value and you know what exactly the hash value of all the data set. You know the hash value. So once the data set gets to your centralized location, you want to hash it to know if it is the same hash value. If it is not the same hash value, it means that the data has been modified in transit. But if it is the same hash value, it means that the data has not been modified in value and the data has what's known as integrity. So uh, the concept of verifying hashing in most cases is known as checksum. Checksum is when you check to ensure that, okay, everything in this part is the same thing that is in this part. Everything from the data feed is what is in this is the same as in the centralized storage facility. Another way you need to ensure that data has integrity is by engaging in data redundancy. Data redundancy is a way of ensuring that you don't just have one copy of your data. Usually, it is recommended that you have your data in three different formats or locations. Have your data in the cloud, have your data on your system, and also have your data in let's say an external storage, physical storage facility like your external hard drive, your flash, and all that. Now, these are the three major forms of data storage. Some organization can decide to, okay, you know what, let's have our data in different cloud platforms. Have one in Amazon, have one in Azure, have one in Google. So Google Compute or Google Cloud. Three different cloud facilities having different data, and they may not put the cloud facilities may be in different locations. They can put Amazon, they put Amazon, my data is in Amazon in the US, my data is in Google Cloud in Asia, my data is in uh, Azure cloud system in Africa. So that's redundancy. And the advantage of that is that once, let's say, if there is a breach in one area, it does not affect. If there's a breach in uh, Amazon, you still have the same data in Azure and cloud compute. If there's a breach in cloud compute, you still have the same data in Azure and Amazon. So data redundancy is having your data at different locations. So if you have important files that needs your important data set that you will need to use to train an AI, it's important that you embed the concept of redundancy. Okay, so encryption techniques. Encryption techniques. So, like I said earlier, one of the key system of embedding encryption is ensuring data integrity is encryption. So let's go deeper to understand some of the concepts and types of encryption, starting with encryption basis. So encryption largely ensures that your data has confidentiality and also has confidentiality, integrity, and availability. In most cases, confidentiality and integrity, thereby ensuring that only authorized persons have access to the data, and also only other authorized persons are able to modify the data. Without the encryption key, you definitely will not be able to modify the data, because for you to encrypt a particular data, you need what is known as an encryption key. An encryption key is a key used in converting the data from plain text to ciphertext. And there are two major types of encryption. There's what's known as asymmetric key encryption, and there's what's known as symmetric key encryption. So asymmetric key encryption, they are largely for asymmetric key encryption, it is same key for encryption and decryption. So for symmetric key encryption, it is the same key you're using to encrypt and decrypt. So what that invariably means is that I want to send data to a particular person, or as a data feed, I want to send data to uh, an AI actor who is developing an AI system, and I am using symmetric key encryption, which means I'm using the same key. So I will encrypt with that key. I will use a different channel to send the key to the AI actor and transfer the data using transfer the encrypted data, which is in ciphertext, using a different channel. So once the AI actor gets, or the AI developer gets, that particular data, what they need to do with that data is that they are supposed to now change that data from cipher back to plain. What they need to, before they can change that data from ciphertext back to plain text, they would need that same encryption key that I used to encrypt it before sending it to them. They will need to use that same encryption key to decrypt At this point, changing it from cipher to plain is decryption. Encryption is changing it from plain text to cipher text. So once I encrypt with a cipher, an encryption key, it needs to be that same key needs to be used to decrypt it. So that system is known as symmetric key encryption, single key for encryption and decryption. An example of that is when we're storing files on our hard drive or on our systems. Most of our file storage systems make use of symmetric key encryption. The same key that you're using to encrypt is the same key you're using to decrypt. However, there is another form known as asymmetric. Asymmetric key encryption uses what is known as a public and a private key, which are key pairs. So key pair would mean that the public and the private key they understand each other. So you use the private key, use the public key to encrypt, and you use the private key to decrypt. So you can give the public key to anybody that wants to send you a message. Your public key, you generate a public key, you give it to anybody that wants to send you a particular data. Once the person will now use your public key to encrypt that data and send the data to you. So because your public key understands your private key, you will now use your private key to decrypt the data that was sent to you. So the asymmetric key is a single key system. The symmetric key is a single key system. The asymmetric key is a pair key system whereby there is a public and a private key. So the public key is used to encrypt, the private key is used to decrypt. And this is largely how web applications function. You find out that when in that padlock that you see on a website, when you go to a particular website, you see one padlock at the address bar showing that that site is secure. What it's actually telling you is that the site has been encrypted, the transmission is encrypted. So the public key is in any browser that wants to go to that site. Any browser that wants to go to that site or wants to access that particular site would use the public key of that site to encrypt. So once the request is sent to once the request gets to the web browser would decrypt with the private key. So there is the public key and there is the private key. So then there is what's known as application in how do you apply AI how do you apply security in AI systems. The first is that you need to ensure that there is secure communication between the data source and AI model. So, like I said earlier on, the developer in most cases would not have the data. So they need to get the data from different sources. So those sources need to send the data securely to them. If the data that is being sent is not sent in a secure way, there is a possibility for the data to lose integrity and modification can happen to the data, thereby ensuring that the data has the potential of being poisoned. And being poisoned would mean that the end result of the AI model would be inaccurate or would be a Trojanized model. Anyway, most of all of these concepts were treated in our mastering AI security course. So it's something that you should consider going. It's something you should consider enrolling for. Mastering AI security on Udemy. Yeah, mastering AI security on Udemy. It's an extensive course that tends to capture most of all of this. So it covers a whole lot, the components of AI systems, what forms AI systems, CIA triad of AI systems, best practices, training, adversarial training techniques, um, what's it called, types of adversarial training, a whole lot. And it's something that I encourage all of us. You learn a lot from the course. Anyway, so protecting sensitive data. Another reason why we need to embed security in AI system is because we need to protect the sensitive data that will be used to train the AI model, especially in sectors like healthcare and finance. Healthcare would need patients records. Finance will need bankers, banks. We need the transaction of users transaction, banking, financial transactions. So we need to be able to ensure that the data within these systems are largely secured. Okay, so now let's go deep into hashing. Hashing was also another techniques that we treated in previous in data integrity. So what is hashing? Hashing is a cryptographic method of verifying data integrity. So like I told us, I explained to us that hashing generates a fixed value, Hashing generates a fixed value, a fixed strange value. And as long as the content of the data is the same thing and nothing has been added or removed, that fixed value would be the same thing anywhere in the world. But a if something has been changed in that data, the fixed value is going to change. As simple as small as full stop or comma, that fixed value is going to change. So it's important that we understand the concept of hashing, which is a method of verifying if a data has integrity. So there are different types of, I've been mentioning algorithm, or algorithm engine. There are different types of algorithm engine for hashing. So hashing has there is SHA-256, there is SHA-512, there is MD5, there is MD4. And there are a whole lot of hashing algorithm, and also encryption algorithm has its own different types. But we need to take note of the fact that uh, hashing is largely quite difficult to break at this point. But that is would only be possible, it will continue to remain that way until quantum computing comes to play. Because quantum computing is a system of, in fact, one of the risks to quantum computing is that it's going to make all these encryption hashing concepts, is going to nullify their potency, because quantum computing will be able to break and crack any code at the shortest possible time. And that's a concern, a huge concern, because if the security of the integrity of the data largely focuses on encryption and hashing, and quantum computing is coming to at this point in time, it means that all the encryption and hashing that we think we're using to encrypt our data would be insecure, would be all those would not be able to withstand the would not be able to withstand the computing power that quantum computing is bringing forth. And that means it will be cracked with less amount of time, and that's a huge concern. To that end, new algorithm engine, new hashing algorithm engine, encryption algorithm engine are being developed, and they are developed to be what is known as quantum resistant algorithm, or resistant encryption, or quantum resistant hashing. Hashing largely makes use of what is known as a cryptographic actually makes use of a mathematical equation to be able to determine if a particular concept if a particular uh, value, actually makes use of mathematical equation to determine to verify the integrity of the data, of the data. Yeah, it uses a mathematical equation to determine that. So applications in AI. So we need to ensure that AI logs, ensuring sorry, uh, secure AI logs, ensuring that they haven't been tampered with, and also verifying data sets used for training models. So what we need to do is that for every AI system, we need to ensure that there is a log that determines the input, the output, and what was imputed and what was outputed by the AI. And we need to ensure that that log is secure, so that we can analyze the log to see if there is an issue with the data, if there's an issue with the system, or we need to generally carry what is known as audit. We need to audit the system to know who assess what data has been tampered with, who log into this server that controls all the data. These are all the components we that that we need to secure and verify. So a secure AI log is important. We need to engage in AI audits. AI system audit to audit the AI system. And for you to engage in AI system audit, it means that you need to know what input was sent to the AI and what output was the AI gave. So then you analyze it using the auditing techniques. Then we need to verify data sets used to train AI. And there are different system ways you can verify data sets in AI training. One of it is engaging in what is known as data versioning, creating version for every set and encrypting every particular version so that one is able to engage, one is able to uh, carry out, uh, one is able to verify, uh, one is able to not verify, one is able to reverse if there is an issue. So if you have version 1.0 data set and you have version 2.0 and you find out that version 2.0 is not giving you what you want, you can always reverse back to version 1.0 since you know that the data used for it is largely uh, works fine and is okay. So that's that for data integrity. Then in conclusion, AI system is critical. AI systems are powerful, but comes with an unprecedented risk. And it's quite important that we understand that security should be a foundational concept in AI system development or AI system development lifecycle. And we need to ensure that we protect the AI systems and not only the system but also the users because there is the ethical concerns and that's also another area that we need to focus on. Then there are ethical concerns. This particular webinar is focused on security, but subsequent webinar I think we'll be looking at AI ethics because there is actually a new job role as an ethicist, not atheist, ethicist. So ethicist. So uh, as AI evolve, we need to also make sure that we change our strategies because it's a new field and it's a dynamic field. That would mean that a whole lot of things will be changing in no distant time. So we need to keep ourselves abreast in this technology and while engaged for those of us who wants to get involved in AI wants to become AI security professionals, this is the course you need to take. You need to go over this content and also enroll in our mastering AI security course. More content, more courses will be uploaded on Udemy probably before the end of the month. We'll add more courses. So let's take note of that. It's an evolving field, it's dynamic, so we need to also stay abreast, stay updated to the course. AI security is important and fundamental and a foundational necessity in AI development. So that is that. Quickly, I'm just going to make mention of that. That's that for the webinar. Quickly, I'm just going to make mention of the fact that for those of us who our Udemy course coupon will be sent to our email. So if you have not registered for our course, I will send a link here. Uh, so if you have not registered for registered to this particular webinar, you still have the option of registering. I'll send the link to the group chat. Go register so that you can get your uh, free coupon. You can get your free coupon if you have not registered. So, but only those that register would get their free coupon. The coupon will be sent to their email. Please also take note of the fact that if you don't receive our email in your inbox, it's possible that it has gone to the spam. So check for email from hello@htcacademy.ng, which is where we're sending all our emails through. So it's important for me to make mention of the fact that we are a 5-day career course has been prepared, that an extensive career, whether whether you are new to security, you don't understand what security is all about. You don't really just come for this course. This course is a power pack course largely designed for those who are interested in building a career in AI security. And whether you are newbies, you're just starting, you don't know anything, the course is so foundational that it starts from its roots. We're going to start you right from cybersecurity and build you up to AI security. And the course is just for as low as $200. So $200, you can actually go to our website to register uh, for the course. You can go to our website and apply for the course, our career course. And the career course for our career course is going to be from the 28th of this month, a 5 day, 4 hours per day live class session throughout, 4 hours per day live class session. So it's going to be from the 28th to the 2nd of November. So if you've not registered, if you intend to register, you want to make further inquiry about the course, feel free to send us an email at hello@htcacademy.ng. I think that's generally that. Yeah, please subscribe to this channel, because this channel would always subscribe and turn on your notifications, so that if we are starting any new, if we're putting on a new webinar, if we're launching a new webinar on AI ethics, yeah, which is going to be our next webinar, you will be notified once the webinar commences. So it's important that you subscribe on this channel and also turn on notifications, so that you can get notified once we're starting our webinar. So that is generally that for the webinar for today. And I hope you enjoy. If you have any question, please feel free to send us the questions or inquiries. Not on the webinar. You will have the opportunity to send your questions either to the Udemy platform, or you send your questions to ask your questions during the career class program. You won't be able to ask questions directly on our webinar. So during that, you can ask your question either on the Udemy course once you enroll and you start, or you can ask during the career classes. So thank you so much for your time, and see you in our next. Yeah, it's quite important that I take note of this. We are also doing a LinkedIn live. Yeah. So starting from next week, we'll start our LinkedIn live 30 minutes every 30 minutes, 3 times a week. So you can go to LinkedIn and follow us at HTC Academy, HTC Academy NG. That's our YouTube and LinkedIn profile user ID. Or you can also follow me on LinkedIn, because I will always share content from the HTC Academy. You can follow me on Haniel HJ on LinkedIn and every other social media accounts. So for the academy, it's HTC Academy NG. For following me is Haniel HJ on all social media accounts, including YouTube, Facebook, Instagram, Twitch, LinkedIn, and Twitter. Yeah. So that's that. Thank you so much, and see you in our next. I hope to see you in our LinkedIn live. So thank you.